Section 1.5 is discussing significant figures and how to determine what which digits in a number are significant. So we're talking about measured numbers. So things like when you go into the lab and you're measuring the volume and you're using a graduated cylinder, where can you stop writing down the numbers? What if you stop writing the numbers too soon? When you're using a ruler to measure the length of something, you want to make sure not to stop writing down before you can. Most people actually put not enough rather than too much. So to write measured numbers, first you have to count all the dashes on the lines. But then once all the lines stop, your number's not done. You have to have one more measurement in here. You have to have an estimated number. So if we're looking at a ruler, and we have all these dashes here, and our paper clip, let's say, goes out to here. Okay, we can count all these dashes, but then we have to estimate between these two where the paperclip actually lies. Scientists will automatically assume that that last number is estimated. So if you just count those numbers, they're going to assume that this last number that you counted was actually estimated. It's kind of like when you stand on your bathroom scale in the morning. It might say 151. That means it could be 150.8, or it could mean 151.3. It's somewhere within this range of whether or not to round up to be 151. Because if it's above 5, it's going to run out to 151. If this is below 4 or below, it's going to keep it at 151. So if we look here, so here's our piece of wood here. It falls right there. So 1, 2, 3, 4. There's no more little notches here. So I have to estimate between the 4 and the 5 what the value is going to be. So I'm going to say it's about halfway across. So it's going to be 4.5. Here's our piece of wood again. 1, 2, 3, 4. Now we have these little notches here. So 1, 2, 3, 4, 5. I can count across 5, but I have to estimate before I get to that 6. So it's about halfway to that 6. So it's 4.55. And then the last number, the notches are 1, 2, 3. It's falling right on that line. So if I think it's right on the line, and I don't want to put 3.1 or 2.9 because I know I'm supposed to estimate something, 3.0. That 0 can still be estimated. It's what you think it is. So when are they significant and when is it not? The book goes into several specific rules. I have essentially 2 rules. I have leading zeros and I have trailing zeros. And I do this because I wanted to simplify it. Because if you look at all the rules individually, it can get kind of confusing. So if I just simplify it being leading and trailing, that makes things a lot easier. So leading zeros, as the word implies, we are leading up to a non-zero number. So all these zeros are leading zeros. And they do not count for significant figures. So therefore, there's only 2 significant figures here. Another one would be 0.000579. These are all leading zeros. These 3 at the end are the only ones that are significant. It could just be one leading zero, 0.82. Those are significant. This is a leading zero leading up to that 8. That is not significant. Trailing zeros are the zeros behind. For instance, if I have 1300, these zeros are trailing zeros. Now, there's two circumstances here. It could be with a decimal or without a decimal. So without a decimal, they are not significant. With the decimal, they are significant. For instance, if I have that 1300, there's no decimal written here. Therefore, those zeros don't count. There's only two significant figures here. If I were to put 1300 and then put a decimal at the end, that decimal means that all four of those count. So there's actually 4 sig figs here. If you physically see a decimal there, that makes all those zeros count at the end. If you do not see a decimal, they do not count. So if I said, let's look at the upper right hand corner, if I look at 0.8900, this is a leading zero. It does not count. However, because of this decimal here, these zeros do. So there's actually 4 significant figures here. You will notice that there is some practice of significant figures in your Chapter 1 folder in the Blackboard. Let's take a look at these. I'll give you a minute to think. So if you look at these are leading zeros, so they don't count. There's a 0 at the end. Because of this decimal, it does count. So we have 4 here. We have no leading and no trailing, and so that means all of these count. That means I have 5 here. I have no leading. I do have trailing, and there's no decimal place, so that means there's no decimal point written anywhere, so that means those do not count. So we have 4. Now, exact numbers will always be 100%. There's infinite amount of significant figures here. So, for instance, if we are counting 6 eggs, if you went to the store and got a half a dozen eggs, you're not going to bring home a half an egg. You're going to assume that it is perfect. So it could be 6.0, 6.000, it doesn't matter. That's why it's called infinite. Another example of infinite is definitions. For instance, no matter what, there will always be 4 cups in a pint, in a quart. There will always be 1,000 grams in a kilogram. Those are definitions. Anytime you have a conversion factor or a definition, those have infinite sig figs, so you don't consider those when you do the calculations. So if we look at this, is it infinite or is it a measured number, and so you have to figure out the number of significant figures? 3 coins. We're not going to have a partial coin, so therefore that's something that they counted. So that's going to be exact. So that's going to be infinite. Diameter of a circle, that was measured. So we have 4 significant figures here because it was measured. 60 minutes is equal to 1 hour. No matter what, there will always be 60 minutes in an hour. That's the definition. Therefore, once again, that's exact, and it's going to have infinite. Okay, and that is all we're going to talk about with 1.5 and significant figures. The next video will be consisting of significant figures and calculations.